Hello guys, welcome to Soup Code, and today we are talking another cup of code. We are talking all things synchronized multi-threading. What does the synchronized keyword have to offer to us, and what it's about, and how it can be helpful to our code base implementations in multi-threading in our space or environment as well. So, without wasting any of your time, I really do appreciate you guys watching and tuning into our channel. For those who subscribe, welcome back. And if you're new, please do like and subscribe and hit the notification bell because we're talking all things full stack development in this channel. Spring Boot, back end microservices. We're also doing Angular front end tutorials. We do assist with code reviews and peer programming. So if you have any of those and have questions about any Spring Boot feature, Angular feature that you want us to showcase, please do reach out to us via the comments or social media pages, and we will basically definitely respond to your requests and address your issues at that. So this particular project is available in our repository, so please do check that out on GitHub. The description does have the repository URL, so please do go and check out the code so that you can see our implementation of this particular project. So I'm going to start on the Spring Initializer. As always, we start on the initializer. So first things first, the project is a Maven based. The language is Java. The Spring Boot version is 3.4 as of recording of this video. And as always, I would say take the latest stable version of Spring Boot. And also if you have dependencies, libraries, and any artifacts that you want to add on your dependencies, make sure you always have the latest stable versions of all of those. So yeah, going to the metadata of the project, the group is com.zipcode, the artifact is synchronized microservice, and the name is synchronized microservice. It is a demo project for Spring Boot, and the package name is the group and the artifact name. And then the packaging will be jar and the version will be 17. That is on long-term support, so that is should suffice for what you're trying to do. And then we have our dependencies, not a lot, because we are reviewing some of the Java internal mechanisms or implementations, so we don't need a lot of dependencies. Spring Web should suffice because we're scaffolding a REST controller, and we're going to just use Lombok for boilerplate code in terms of, let's say, maybe logging and things like that. And then DevTools for live reloads on our code. If you make any changes, we would want to bounce the server ourselves, but we should be able to just save and to reboot the application on the fly. So yeah, that's about it on the artifact or the service that we are going to be looking into today. So let's jump right into the demo so that you can see what we expect to happen. So I have a synchronized multi-thread service right here, which is a get sync, and if I run this guy, you will see it will give me a 200. And what happens behind the scenes is it is basically just doing a normal count, just as you can see here. So I will show you how this service looks like just now, and if I run it again, you will see that will continue from 6. It says 7, 8, 9, and if I do that again, it's going to continue to increment to 10, 11, 12, and that's the power of the synchronization that we have within our code base. So let's go into the service itself and the controller so that we can showcase how this code base is set up. So currently we have a sync controller. That sync controller has two annotations: at rest controller, to make sure that Spring is aware that we are scaffolding a new API endpoint, and the request mapping for the controller is sync, just like we have this side here. Our server is running on localhost 8080. That's by default in Spring Boot application, and then we have the sync endpoint that we want to hit, which is this request mapping over here. And with that, we then have a dependency injection, which is auto-wired, this private sync service, and we're going to use that as our business logic layer. So after dependency injection, we have our get mapping. Hence, we have the get mapping right here, which is the get endpoint that we're calling. And that get mapping then is just a sync, and then it throws an interrupted exception because we're going to be running multiple threads. So let's see how those get to be kicked off. So in this particular example, we have 3 threads that we are going to create. We have thread 1, we have thread 2, and we have thread 3, just like that. And once these threads have been created, what we do is start those threads, and then we join these threads into the main thread. So when you say thread.join, it means we want the main thread to basically await all of these threads to run and finish, and once they're done, then it can come back and respond to us. So that's what we have. And now that we have that, I just want to show you what the threads are doing. So thread 1 is basically just a runnable. It has a runnable within it, which is a code block that it's going to execute, and we want to run a sync service update. And we go to sync service.update. You will see that we going to the sync service class, which is just an annotation of its service. That Spring Bean that is going to be available for our business logic. And then we just have one field, which is a public int count. And then we have this particular update method that we call here. And this update method doesn't do anything fancy. It just increments count as much as we basically call the update method. So it's only, or it has solely a single responsibility, which is just to increment count and basically just assign the new value back to count. And if you have been in a multi-threading environment or implementation, you would know that if you are working on an object or you are making use of a method in multiple scenarios, or you're accessing that in multiple places, you definitely guarantee that there will be updates that will be coming in as you run your particular process. So in this situation, let's say, for example, I remove this synchronized keyword, and I'll show you in a bit what this will do. Let's just allow the application to refresh. So yeah, the application has refreshed. So now I've removed the synchronized keyword from there, and I send the request again. And when I come back to here, you can see that the count is still fine. It's looking fine. It's 1, 2, 3. But if I run the endpoint again, it's able to synchronize. Let me just stop it and rerun it again, because what we are going to have here, now that we've removed that synchronized keyword from the update method, you will see that what is going to happen is a scenario which is unintended, and now the server is not actually picking it up. Okay, let's go back to the controller. The count is still synchronized, which is fine. All right, so now it started up. Let me send it again, and then let's see what it looks like. Okay, it still looks fine. So what we are doing in these threads, we are basically updating the count, and then after updating the count, we're printing out the count just like we're doing here. And in the same way, in thread 2, that's what we're doing. In thread 3, that's what we're doing. And then we, once we've updated the count 3 times, have printed it 3 times, we just start all of these threads and we join them, just like I mentioned a few seconds ago. And once all of these have executed, we want to see these values showing up. And now my application server is still picking up that the update method, which is the code block that we want to synchronize, it's picking up that it's still synchronized, of which it's not. And in a scenario where the method is not synchronized and you are accessing this via multiple threads, what you are going to experience or what you are going to come across is that count can be updated or modified by multiple threads at the very same time. So, which this basically means that thread 2 and thread 3 can, at any given point in time, update the value of count at the exact same time, and instead of you having 1 2 3 as a result or as the expected result, you can have a scenario of 1 2 2 or 1 1 2 or 1 1 3 or something to that effect, where the results that you expected are not according to the execution of your particular thread, and that is called a race condition. So a race condition is where you have multiple threads that are working on the same or relying on the same method, having to be updated, or the object within that method having to be updated on the fly simultaneously, thus giving you undesired results. So in our case, we're going to keep on trying to run this without the synchronized keyword, because if I put back the synchronized keyword, it is always guaranteed that you will always have a synchronized result where your object will be updated as and when required. And if a method is working on the if in the synchronized let's say if your process is working on a synchronized method, then your results are always going to be guaranteed, and it is going to basically allow a single access to that particular method. So even if I have multiple threads updating count, they would have to wait for one particular method to finish updating count. Then it's basically going to release the update method for another process to call it, or a different thread to call it. So in a sense, you can say that once you have synchronized keyword in your method or a synchronized code block, what it will do is it will lock that particular method or that particular code block. It will lock it for one method to access it, and once that method is done executing, it can only release the lock and make it available for other processes to run or for other threads to call it. So in this scenario, once we have the synchronized keyword, if synchronized is if the update is called on thread 1, it will only wait for thread 1 to finish working with update and only release it then and make it available for other threads to call it. So once thread 1 has updated count, then it will throw it back and say now update is available, and then thread 2 and thread 3 can basically execute or update update count on the fly, and they can do that simultaneously because in a multi-thread environment, threads don't really have like a synchronized way of doing things. They execute randomly. So those updates are basically handled according to the synchronization that we have. So if you don't have this synchronized keyword, then you will have that asynchronized type of access to the method, and hence your results will not be as guaranteed as you would have in a synchronized let's say implementation. So let's try it again and see if the server is going to pick up that our method is synchronized or it's not synchronized. So we're going to try again with synchronized, and we're going to see that it's going to give us 3 counts 1 2 3, which is what we expect. However, if we remove so you can see that 1 3 2, so it's able to count, but the threads, as I mentioned, they execute randomly in a multi-threaded environment. So it's not always guaranteed that you'll always have 1 2 3, but it will always have a 1, a 2, and a 3, because once the method is released for access, it can be accessed by any of these threads that are executing at that particular time. But what we want to do is see a scenario where the synchronized keyword is off, and let's just wait for it to restart, because in that scenario you will realize that You won't always get a 1, 2, 3, but however, you can run into a scenario where you will get a 1, 2, 2, or a 1. Let's see. Let's hope that the server picks it up, because then if it doesn't, then it doesn't prove our point. It keeps on synchronizing, which is weird. Let's save this. At times it's weird like that when you are basically showcasing a code, a snippet of code, and then it doesn't behave the way that you expect it to. That will be demons, I tell you. But let's see. Let's try one last time. Otherwise, we can just leave it as is, or we can just increase the number of threads, and we just see if it basically gives us the response that we expect. Okay, cool. Let me just add the number of threads this side, because it's not like we're doing anything fancy. So let me just add 2 more threads. And you can also create these threads, let's say, in a loop instead of just hard coding them like I'm doing here. So you can just create a for loop and then create an iterator that will maybe execute this 100 times or 1,000 times, and then you basically just watch those threads execute, and you'll realize the execution of all of these threads, that it won't always guarantee you the expected results. In terms of, if you have 5 threads, you would expect it to print 1 to 5, but in some instances it will duplicate the response because of that concurrency that is happening with the race conditions, as I mentioned. Okay, let's say okay, and let's see. So when I just run these 5, and hopefully it picks up that. All right, let's run that. Let's have a look. Yep, here it is. So you can see that we have 5 threads, and we're expecting 1, 2, 3, 4, 5, and it has 2, 4, 3, 3, 5. So now it picked up that this method over here is no longer synchronized, and because of the race conditions, you see that 2 threads were working on count on the first execution, because we were supposed to get 1, we did not. We got 2 as the first print out, which means the 2 threads were manipulating or modifying count at the very same time, and we got that response back. And by the time we went again, you see that we have 4 over there, and then we have 3 over here, and then we have 5 over here. So this is the inconsistency that we're talking about when you have a code block or a method that is unsynchronized, and it doesn't conform to any of the modification rules that you would expect in a multi-threaded situation. So it's better if we put this back and we say, let's put this on, make it synchronized, and then we save that, allow the application to run, and we then just call that sync endpoint. Now let's see. Now you see 1, 2, 3, 4, 5, and it's now synchronized. It's giving us desired results. So this is not only a matter of count, but it's in a multi-thread situation where your processing might be complex, but you realize that I need the results that are as reliable as possible, so that my processing will be as accurate as possible. So you need to basically synchronize that and to handle your race conditions accordingly. There are other locking mechanisms that you can implement with Java's internal lock, or you can also have atomic classes, let's say maybe like atomic integers, atomic longs, and things like that, that you can use in situations of, let's say, numbers or similar scenarios where you are handling increments and things like that. So this gives us that atomicity in the operations that we're doing, and it basically guarantees that our results are as accurate as far as possible. So let's just remove the synchronized keyword again and save this, and we will just run it for one last time just to see the two contrasting results or outcomes. Let's go back, and as you can see, we remove the synchronized keyword, and you see 2, 2, 3, 4, 5. So 1 is not there, which means our threads, as they were executing, they were all accessing the update, and they were updating and modifying count simultaneously. As you can see, the duplicated result here. But once we put back synchronized, we only have each thread is going to access and modify count at a single time. And once the thread is done, it's going, the update method is going to be available for the next thread to take, and for the next thread to take, and for the next thread to take. In that similar fashion, this is how you basically maintain synchronization across your threads. And basically that's it for this tutorial, and I hope it comes in very handy to assist you in understanding synchronization, how you can use it, and where you can basically plug it in your multi-threaded environment or scenarios where you would need to maintain some sense of synchronization in your processing. So until next time, for now, please do like and subscribe. Cheers.